Welcome back to another episode of Dave Does Math from Home. Today's topic is section 1.2a. We're doing linear equations. This is actually a pretty severe departure from what we were doing in the last chapter. For all of the last videos, all the P1s and through the P6s, the entirety of chapter P is all about expressions, which we talked about at the beginning. Expressions are they're collections of things. They don't have equal signs, which means the only thing that we can do with them is simplify them. We can mess with it, we can combine like terms, we can factor them, we can expand them. But our options are honestly very limited because there's no equal signs there. So with this section, we are moving into equations, which is very exciting because now we're going to have equal signs, and that's going to give us a lot more freedom to do things. So equations are good. We like equations. They let us do lots of cool, fun things. Hopefully we recognize the word linear. I mentioned this word before in section P4 when we were introducing polynomials. Specifically in terms of the degrees of polynomials, we said that different degree polynomials had different names. Third degree polynomials are cubic, second degree polynomials are quadratic, first degree polynomials are linear, and 0th degree polynomials are constant. So that's the same word that's being used here. Linear here means first degree polynomial. And again, polynomial means no weird stuff. First degree means only x's. The only variables present are going to have exponents of 0 or 1. No weird stuff. Highest exponent is 1. And equation means has an equal sign. Which is good for us because when something has an equal sign, that means we can do literally anything we want to it. Some of the things we can do to it aren't helpful. So some of those things we shouldn't do, but we're allowed to do them. We're allowed to do anything we want to equations. You want to double both sides? Do it. You want to square both sides? Knock yourself out. As long as the things that you're doing to the equation, if you do it to both sides of the equation, you'll still have an equation. It'll still be true. So you can do anything as long as you do it to both sides. That's why equations are super fun. That's why I like equations so much. So, as an example, we might see something like 2 times 3x minus 7 equals 4x minus x plus 2. So we can quickly verify that this is in fact some sort of linear equation. We can tell it's an equation because there's an equal sign there. We'll check that off our checklist. We got the equal sign, means it's an equation, we're all set. It's linear because there's no weird stuff, and the highest exponent is 1. Nothing is being squared or cubed or taken to the 4th power. No weird stuff, there's no square roots, there's no division by variables, there's no trigonometry, there's no logarithms, no exponentials. So, it's all very simple, nice, easy. It's about as easy as these things get. Or I shouldn't say easy. If you struggle with these, me calling them easy will not help. Straightforward, I think, is the word I meant to use there. These are about as straightforward as they get. No weird tricks, no shenanigans. To solve these things, we're going to use a pretty straightforward technique. Step 1 is distribute things. So you distribute the 2 in here, You distribute the negative sign in here. So this would be 6x minus 14 equals 4x minus x minus 2. Then we combine like terms. Nothing to do here. 6x and 14 don't interact. Here we have 4x minus x. That'll give us 3x minus 2. And then we move x's to one side and constants. Constants are the terms that don't have x's in them. If a term has an x in it, it varies. It's variable. If a term has no x's in it, then it's a constant, because it doesn't vary. It stays the same. Constants to the other. So I'll subtract the 3x from both sides, so that this side cancels and this is just 3x. And I'll add 14 to both sides here, so that this cancels and that's just plus or equals a positive 12. And then we divide by the coefficient. So if you divide both of these sides by 3, you get x equals 4. And that's it. That's your solution. Quick note on word usage, because for reasons, I'm not entirely sure of the reasons, but whatever the reasons are, this is vaguely important to me. If you have an expression, like the stuff we dealt with in chapter P, you simplify the expression. You cannot solve an expression, because that's not what the word solve means. Solve, I think lots of students think that the word solve means get an answer. And that's not what solve means. Solve means isolate. So this is considered solved because x is isolated. There's nothing else happening to the x. Here, there's a bunch of stuff happening to the x. It's being multiplied by 3, you're subtracting 7, that whole thing's being multiplied by 2. Over here we have other x's, one's being multiplied by 4, one's being added to 2, and then that piece is being subtracted. All kinds of weird nonsense is happening to these x's. By the end, after our manipulations, x is by itself. That's what solve means. Solve means make something be by itself, on one side of the equals sign. So the other side of the equal sign can be whatever you want it to be. But the only x should be by itself on this side of the equal sign. That's the solution. That's why you can't solve equations. They don't have an equal sign that you can use to isolate things or separate things. It's just a thing by itself. You can't split it up. You can't isolate anything. So equations we solve, expressions we simplify. I want to do another example with just random numbers, and then I want to talk about what to do with fractions, and then that'll be about it, I think. Let's do 5 times 2x minus 3 plus 4 equals 6 times 4x minus 1 plus 2x. I'm just making up these numbers. I have no idea whether or not this is nice. I was actually pretty surprised that the last one worked out to x equals 4. I was sure that that was not going to work. Or at least that it was not going to be nice. So, this one, let's just do the steps. We'll distribute first. 10x minus 15 plus 4 equals 24x minus 6 plus 2x. Check. We'll combine like terms. 10x minus 11 equals 26x minus 6. Check. Move the x's to one side and constants to the other. I'm going to subtract the 10x from both sides because it's the smaller one, and that keeps this positive. Cancels these guys. Now I get 16x. That means I need to move these 6's to the other side, so I'll add 6. And I'll get negative 5 equals 16x. That's not the final solution. That doesn't get a box. I think I just instinctively put a box on it because it was at the bottom of the board. 16x equals negative 5. Now I have to divide both sides by 16 to get the x by itself and isolate it and solve. And I will get x equals negative 5/16. One of the things that the homework is going to ask you to do a little bit of is check your solutions, verify your answers. And to do that, you can just plug your x value right into here and make sure you plug it in here and here and here, and then do all of that arithmetic and make sure that both sides come out to be the same number, which I should have done in the last problem when x was 4. I kind of don't feel like doing it on this problem when x is negative 5/16. So trust me that you can plug this x value into here, and hopefully you get that it verifies and both sides are even. Instead of doing that, I want to do a different thing, which will help, because sometimes on some of these problems we're going to end up with an extra step 0. I want to talk about that. So sometimes we're going to get linear equations that look like 4/3 x minus 6 equals 1/7 x plus 5. And this looks crazy because this is a little bit crazy. No one likes fractions. No one likes working with fractions. But here we have fractions. So fractions are part of why I like equations so much. Because when you have fractions in an equation, you can just get rid of them. That's what makes equations so beautiful. I'm going to erase the title of this thing. I never do this. I like keeping the title up, but I need to add our extra step. Sometimes step 0 is clear the fractions. You can always clear the fractions just by multiplying by the denominators. Like, if you don't want there to be a 3 here on the bottom, multiply everything by 3. 4/3 times 3 is just 4. It's 4x minus 18 equals 3/7 x plus 15. As long as you multiply everything by 3, you can just get rid of fractions this way. We still have a fraction here, so I'm just going to do that again. Let's multiply everything by 7. The numbers will get big, but I'd rather deal with big integers than fractions. No one likes fractions. So this will turn into 28x minus 7 times 18 would be 70 plus 56, so 126. Is that correct? Yeah, that's right. 28x minus 126 equals 3/7 times 7 is just the 3. 15 times 7 is 70 plus 35 is 105. Not so bad. Beats working with fractions anyway. So we have cleared the fractions. We don't have to distribute anything. We don't have to combine any like terms. We can skip right to this. Move the x's to one side and the constants to the other. So I'll subtract 3x from both sides to cancel this guy. And that leaves me with 25x. And I will add 126 to both sides to cancel that. That'll leave me with 231, which is not a pretty number, but I don't need it to be pretty. All that's left to do is divide everything by 25. And you get x equals 231/25. I'm going to go ahead and once again not check this because I don't want to multiply 231/25 times 4/3 and then times 1/7 and see if that works. That would be a mess. I'm just going to trust that this is correct. But if you have a calculator and you want to plug it into this to see if 4/3 of 231/25 minus 6 is the same thing as 1/7 of 231/25 plus 5. You could do that. That's very possible. So, that's it for the basics of solving linear equations. There's a couple more things we need to talk about, a couple sort of corner cases, niche scenarios that might come up in the homework that you need to be prepared for. So we'll talk about those, but I'll put that in a second video, so stay tuned for that.